Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a concept of sleep and negative sleep of reciprocating pump. So in our previous lecture, we have seen that how single acting reciprocating pump is working and how the double acting reciprocating pump is working. So now we'll discuss about the sleep and negative sleep. Both are there. So both are also very simple. So first I will give the definition about the sleep. So I'll write the definition about the sleep. Actually, the sleep is the difference. This is the difference between the theoretical discharge between the theoretical discharge. So let me write fully theoretical discharge and actual discharge. Theoretical discharge and actual discharge. Actually, how much water will be delivered and theoretical how much was delivered. There will be some difference between that. Like there is some changes of value will be there in that. Okay, so how the changes will come, that I'll tell you. Okay, why it is happening. So as per this definition, the difference between the theoretical discharge and actual discharge. So theoretical discharge, we know that we used to just mark it QTH. Okay, and actual discharge, that is marked as Q actual, or you can write Q act, like that. So here I can write sleep, because as per the definition I can write this QTH minus Q actual. This is the formula for this. Now, what is theoretical discharge and what is actual discharge? So in the last two lectures, we have discussed about the single acting reciprocating pump and double acting reciprocating pump. In that, we got the value of for QTH equal to, and what we have discussed, that is actually theoretical discharge. So that value we got here, this is ALN by 60. This value we got for the single acting reciprocating pump. This one we got for single acting reciprocating pump. And the same thing like QTH we got here 2LALN by 60. And this value we got for double acting reciprocating pump. These two things we got in our last lecture. Okay, and there we can see how we got this one. Okay, so as per this definition, what it indicates that the theoretical value, that Q discharge, will be greater than Q actual. Okay, the theoretical discharge is greater than the actual discharge. Actual discharge is nothing but practical discharge. Practically, how much you are getting. Okay, if you do the experiment, from that experiment, how much value we are getting. But theoretical, we have some values are there. These are the values are there. Based on that, we can calculate. Okay, and then we can compare how much is there. Now, suppose by this formula, we got the discharge value. Suppose we got 20 meter cube per second. Okay, 20 meter cube per second of liquid was delivered. So when you see this theoretical discharge, and actually if you measure actually how much how much discharge happened, suppose 18 meter cube per second of water was delivered, that is Q actual. Now see that the 2 meter cube, the difference between this, how much you are getting, that is, suppose if I consider here 2 meter cube of water per second. So with respect to second 2 meter cube of, or see, it may be 2 meter cube. Okay, it may be 0.02, 0.01, 0.05, whatever it may be. But with respect to second, if this much difference is coming between the theoretical and actual, okay, then the calculation will be very critical. Okay, that's why you need to first calculate the slip while you compare these two things. Theoretical is how much, actual is how much. So the next was, okay, why this, the next question is why this theoretical discharge is greater than the actual discharge. Actual, what is the problem? Why the actual is less than this one? Because in the actual discharge, we have issues. We have some issues are there. In the actual discharge, actually some problems are there in the pump. Problem is nothing but problem actually. Some issues are there, due to that we should consider the actual is come less. Some leakages should be there. Okay, due to some leakages, and the leakages of water Okay, and that should be like where the leakages you can ask. So the leakages of water, there is only one way, that is the pump, like through the piston. Okay, leakages of water through the piston maybe, and due to that it may be happen. Along with these leakages, also we can consider some friction losses are there. Some friction losses, or we can say some valve is there. If the valve is moving, then some valve losses will be there. Okay, and along with that also we can consider some air leakages may be there. Okay, so these are the some assumptions are considered of these losses. Okay, that's why in the Q actual will have less discharge, okay, than the theoretical one. So this is one point, but this is sleep. But thing is that how the sleep used to determine, like how the sleep used to expressed in which term. So the sleep used to express in the percentage. So the sleep is expressed in the percentage of sleep. Okay, and the percentage of sleep, how we can calculate? So this is very simple. Percentage of sleep is nothing but we can write Q theoretical minus Q actual by Q theoretical. Q theoretical into 100. Percentage we need to do, that's why 100 need to be multiplied. So in that we can write Q theoretical by Q theoretical, that is 1 minus this is Q actual by Q theoretical I can write, and let's keep it in bracket, into 100. So finally we can write how this percentage of sleep can be calculated. So the percentage of sleep can be calculated is equal to 1 minus Qx by Q theoretical, that is 1 minus CD. I'll tell you what is CD, into this bracket close into 100. Now the CD is nothing but coefficient of discharge. So the CD is coefficient of discharge, and that can be described by Q actual by Q actual by Q theoretical. The same thing is there, Q actual by Q theoretical. Okay, this can be calculated. Yeah, this is coefficient of discharge. Yeah, done. So the next thing is what? Next thing is negative sleep. Okay, so first one I hope you understand what is sleep, and the second one I'll tell you what is the negative sleep. So negative sleep is slightly like reverse to this. Negative sleep. Okay, so negative sleep is actually, this is the difference, like this is not the difference actually. If I consider if the actual discharge, okay, if the actual discharge is greater than the theoretical discharge. Here what I told you, when the theoretical discharge is greater than actual discharge for this condition, sleep difference. Okay, now if the actual discharge is more than the actual discharge is more than the theoretical discharge, then the sleep of the pump becomes negative. Then the sleep of pump became negative. That is called negative sleep. Okay, so that is called negative sleep. So why this happening? Like why this negative sleep occurs? Actually, what is the reason for this? The reason behind this negative sleep is, so we need to consider few reasons are there. I'll tell you. When delivery pipe will be very small, when our delivery pipe is short, this is one reason. When the delivery pipe is very small, then the negative slip occurs. Second point I can say, like pump speed is very high. When the pump is rotating, when the pump is moving with high speed, that means pump running with high speed. This is one more point. Okay, and third point I can say, our suction pipe here, delivery pipe, along with our suction pipe also need to consider. When the suction pipe is short, sorry, suction pipe is long. If you observed, mostly suction pipe will be always small only. Okay, delivery pipe will be, we have large, long pipe will be there because that need to be delivered. So due to these are the reasons, okay, our negative sleep occurs. Okay. So I hope you understand this theory. If you are having any doubt in this, you can give a comment on the comment box. This is a very, very simple theory. There is no complex on this. Easily you can understand. And always we'll try to avoid this kind of consequences. Okay. Because when to run the pump properly, these things also need to be checked. The sleep and whether sleep is positive or negative. So I hope you understand. If you're having doubt, you can give a comment on the comment box. Thank you all.